Now, like most people, atoms don't usually share this in an equal way. Um, I know that when I share something, it's always me or the other person who prefers to have more of it. And that preference of how strong something is and how much it demands more is what we call electronegativity. Electronegativity, nice big long word, and that is basically a measure of an atom's attraction to electrons. So if atoms like to have electrons and they pull electrons towards them, they'll be like fluorine with this big high number, what this is for. If they tend to stay away from electrons and they don't pull them, then it'd be like francium down here, where the number is zero point 0.7. Now, this system was devised by another American chemist. This is Linus Pauling. He came up with this system back in the 30s, and he won 2 Nobel Prizes. One of them I know was for vitamin C. I forget what the other one was for, but he became a very famous man. He was, I believe, one of the only people to win multiple unshared Nobel Prizes. But anyways, we can actually tell the covalent or ionic character of a bond by using Pauling's system. So let's say we have something like NaCl, for example, sodium chloride. Sodium's electronegativity number is 0.93 and chlorine's is 3.16. Now if we subtract these, we'll get a number greater than 1.7, which means NaCl is ionic. Whereas if we have something like H2O, H is 2.2, O is 3.44. Let me pull up the calculator really fast so that I don't have to do the math. 3.44 minus 2.2 equals 1.24. So this would fall somewhere in here. So this is what we call a polar covalent bond. Polar meaning that the electrons are more highly attracted to the oxygen than the hydrogen. So if we drew out this bond, it would look like that, and all the electrons in the bond would be closer to the oxygen than the hydrogen. So because there isn't an even distribution of electrons in this bond, therefore, the oxygen doesn't like to share it very well, then this is a polar bond. And because there's more electrons here than here, you get these cool little poles. And these are actually partial, so we put lowercase delta. And within this bond, we have, what do you know? A partial negative and a partial positive charge. So that's basically bond polarity. And again, it sounds really complicated, but all you really need to know at the very basic level is that atoms don't share their electrons completely equally. So this is a way that we measure how well they share their electrons. And if there is an electronegativity of difference of 0, we call it a coordinate covalent compound. So let me give you a second to think about when a coordinate covalent compound might form. Now, you see some compounds on this periodic table, or some chemicals in this periodic table that have similar values, but in order for you to have a coordinate covalent compound, the ionic character must be absolutely zero. So something like one of our brother Honcliffe elements, let's say diatomic oxygen, there is an oxygen bond here, and it's actually an oxygen double bond. And because that these both have the same value, x minus x equals 0, and that would be a coordinate covalent bond. So coordinate covalent bonds only happen with two of the exact same element. Okay, so now that we know all about what valence electrons are, how they're transferred, and also how atoms like to share them, let's talk about actually making these bonds.